Hi, this is King of Review. Find the points of intersection between y equals 5x plus 3 and x squared plus y squared equals 25. One method for solving this problem is to use substitution. So I have an equation that solves for y here. Y equals 5x plus 3. So I'm going to substitute 5x plus 3 into the second equation for y, like this. What does this look like? We have x squared plus y squared equals 25. Notice I left an open space for y. I'll now substitute 5x plus 3 in for y, so that goes in the parentheses. Now let's expand this portion. X squared plus 5x plus 3 times 5x plus 3 equals 25. We have x squared plus, and I'll use FOIL to multiply this out, 25x squared plus 15x plus 15x plus 9 equals 25. Now let's combine like terms. 26x squared plus 30x plus 9 equals 25. Now I want to have a 0 on one side of the equation. So let's move the 25 over to the left. I'll subtract 25 on both sides. Now I have 26x squared plus 30x minus 16 equals 0. Now, are there any common factors between these three terms? Yes, 2 is a common factor, so let's factor out a 2. We have 2 times 13x squared plus 15x minus 8 equals 0. Our equation is now in the form ax squared plus bx plus c equals 0. When we have an equation in this form, we can use the quadratic equation to solve for x. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac, and this is all divided by 2a. The a, b, and c values come from these numbers here. So on our equation, a equals 13, b equals 15, and c equals negative 8. Let's apply these three values to the quadratic equation and solve for x. We have x equals negative 15 plus or minus the square root of 15 squared minus 4 times 13 times negative 8. And this is all divided by 2 times 13. When you simplify, you get negative 15 plus or minus the square root of 641, and this is all divided by 26. Now you're going to get two values for x. One is calculated using this plus sign, and the other is calculated using the minus sign. So use your calculator to solve for x. We get x equals 0.397, and we get x equals negative 1.55. So these are the two x values. These represent the x coordinates of the points of intersection. Now let's find the y coordinates of the points of intersection. We can do this by plugging in each of these x values into either one of these two equations. I'm going to choose the first equation. This equation is y equals 5x plus 3. So let's plug in our first x value. F of 0.397 This equals 5 times 0.397 plus 3, and this equals 4.98. So we have a point of intersection at 0.397, 4.98. This is our first point for the intersection. Now let's plug in the second x value, f of a negative 1.55. This equals 5 times negative 1.55 plus 3, and this equals negative 4.75. So we have a point of intersection at negative 1.55, negative 4.75. This is our second point of intersection. So letter D is correct. So we use substitution to solve this problem. This is solving it algebraically. We found what these points of intersection are, but you can also solve it using a graphing calculator. You can plug in each of these equations into your graphing calculator and plot the graphs and see where they intersect. I'm going to plot by hand a rough sketch of what these look like. So this first equation here, y equals 5x plus 3, we know that this equation is a line because it's in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So let's plot that line. We have a coordinate plane here with an x-axis and a y-axis. Okay, so I'm ready to plot this line. Our y-intercept, which is the b value, that's right here, that's a 3. So this is where the line will cross the y-axis. It's at 3, which is right here. And the slope of this line is 5. So this means up 5 over 1. So that's right about here. So now we can use these two points to plot our line. So here's our line. And now let's look at the second equation. We know that the second equation is a circle because it's in the form x squared plus y squared equals r squared, where r is the radius of the circle. When we have an equation like this, we know that the center of the circle is at the origin, which is right here, and we can find what the radius is. If r squared equals 25, then we know that the radius equals 5. So let's plot this circle. So we know that the center of the circle is at the origin, and it has a radius of 5, so it's going to pass through these points here. So now I'll just do a rough sketch of what the circle could look like. And here's our circle. So where do these two graphs intersect? Well, we have a point of intersection right about here, and we have a point of intersection that's right about here. So two different points, and we've already solved for these points here. Thanks for watching.